Okay, for those of you at home who missed my instruction or maybe just needed a refresher if you were in class, I'm going to go over maximizing and minimizing objective functions using linear programming. Sounds a lot more difficult than it is. Now, if you remember yesterday, we learned how to create a feasible region using a system of linear inequalities. We'd be given our system of linear inequalities, and based on that, we would graph, we would shade, and then we would find the region that had answers that fit all three of these linear inequalities. And you will notice that for this down here, we have already shaded it in. So I do have an additional video on that if you want some review on that. But for sake of what we're doing, we're going to assume you already have your feasible region. So you've graphed your linear inequalities, you have your feasible region. Now, you'll be given an objective function, at least in this case. In some cases, you might have to do a word problem to figure out what the objective function is. But in this case, you're going to be given your objective functions, which again, work is taken off the table for you. You have less to do. Now, you're being asked to maximize it. So I'm going to go through the steps in this, and believe it or not, it's not as difficult as it sounds. Your first step is you want to identify the corners and vertices of your feasible region. So you want to find the corners and you want to identify the coordinates. So I'm going to go down to here, and I notice, okay, I got a vertex right here, a vertex. So I want to find the coordinates for this. So the coordinates for this would be 6, and then 3, 4, 5, 6. So 6, 6. So remember, that gives me an x and a y value. I'm going to find my additional corners. I go down below here, okay. Got another corner. 15, 0. Again, those are x and y values. First value is x, next value is y. And then I go down to here and I find that last corner in this case, because we had a triangle, it was nice and easy. Coordinates of this are 6, 0. And remember, that gives you an x and a y value. All right, so I'm going to identify these coordinates. I'm going to write them off to the side here. I've got 6, 6, 15, 0, and I've got 6, 0. Now, this problem is asking me to maximize, but I'm going to show you how you can maximize and minimize as well. Now, if you think about the word maximize or maximum, it means getting the most, right? So what you're looking for is which coordinates are going to give you the most, what's going to give you the greatest answer for your objective function here. So I'm just going to shrink these, bring them on over. I'm going to have my objective function, which is 12x plus 20y. And now you're just going to use substitution. As the step says up here, substitute your x and y values from the coordinates into your objective function. The ordered pair that gives you the greatest answer is going to be your maximum, and the ordered pair that gives you the least answer is your minimum. So let's figure this out. All right, so our first set of points is 6, 6. Remember, these are x and y values. Ordered pairs always are. You have inputs, outputs, x, y's. So I'm going to plug in 6 for my x and 6 for my y. And when I do that, I get 192. I'm going to take note of that. Number cases within mathematics, we'll call this z. So we can do that. We can do z equals 192. Next, I'm going to plug in my next set of values. So my next set of coordinates is 15, 0. So for x, I'm going to plug in 15. And for y, I'm going to plug in 0. Oops, I almost wrote y again, but I'm just going to write 0. So then 15 times 12 would be 180. Again, I can call that z. Now, so far, based on what I'm seeing, it looks like to maximize my function, I'm going to have to use ordered pair 6, 6, because that gave me the greatest answer so far. But just to check, we're going to use 6, 0. We're going to see what happens. So I'm going to plug in 12. And then again, x is going to be 6. Y is going to be 0. Plug these in. Again, answer of 72. So let's see, to maximize my function, which ordered pair gave me the greatest answer? Ended up being 6, 6. 6, 6 would be my maximum, or this is what would maximize my function. If I were asked to minimize it, the point that would minimize it would be 6, 0, because when I plugged those coordinates in, I got my least answer of 72. So if I were asked to minimize, this would be my minimize. The point that would minimize my function would be 6, 0. Now, a lot of cases people would look and say, oh, you just went with the top point and the bottom point. But all depends on your objective function, so be careful. Don't just do it based on vision. You do have to check it out. Let's try another one. Now, this one has 4 points, and this one has a few more. We'll try one with 4 points. Okay, so again, we were given a system of inequalities. It's already been graphed for us. This is the function we're working with, 8x plus 12y. So I'm going to identify my ordered pairs. Up on top here, I have 3, 4, 5, 6, 7. So I've got 0, 7. I'm going to go down here. I got 0, 0. I like that. That means there's going to be some easy math involved. Up here, I've got, where are the coordinates? 3, 4, 5, 6, 7, 8. 8, 3. I'm going to go to the bottom corner here, where I get 9, 10, 11, 12. 12, 0. Remember, these are all ordered pairs. So I'm going to use my function, 8x plus 12y, where am I going to get the most space here? I'll have to do it up here. I'm going to start substituting my values. My first one was 0, 7. So I'll start with 0, 7. 8 times 0 plus 12 times 7 gives me 84. Next, I'll go with 0, 0. This one's nice and easy. 8 times 0 plus 12 times 0 gives me 0. Now, I might be inclined to think that this would minimize my function, but let's wait, because you never know. So then we got 8, 3. We're going to do the same thing again. So with 8, 3, 8 times 8 plus 12 times 3. It's going to give me 100. And then last but not least, I've got 12, 0 down here. So 12, 0. 8 times 12 plus 12 times 0 gives me 96. Let me double check to make sure I got everything here. Okay, that was 12, 0. I had 8, 3 right here, 0, 0, and 0, 7. So now, which point maximized my function? Which one gave me the greatest answer? 0.83 it looks like. Even though I'm just going to double check. Oh, I did something wrong. I'm glad I checked this. I'm going to go back. Let's see. Instead of 0, 7 here, nope, that was right. Just want to double check. It's always good to double check your work. And then 8, 3, yep, that checked out. And 12, 0, awesome. So then, what would maximize my function? It would be 0.83, because that gave me my greatest answer of 100. So to maximize my function, I would have to use 0.83. And if I wanted to minimize my function, I would have to use 0.00 in this case, because that gave me my smallest answer. And that's it, guys. Maximizing and minimizing objective functions using feasible regions. It's really not that bad. All you have to do, graph your system of inequalities, identify your corners, and then plug the ordered pairs from those corners into your objective function. Whichever ordered pair gives you the greatest answer, that maximizes it. Whichever one gives you the least answer, that minimizes it. Hope this helps, and best of luck.